All right, so we're going to start recording where you just see the equations we wrote down for the first part. Pause that if you need to, and we're going to go into the example. It's R. Everyone says hi, Cade. All right, so on the back here, find dr d theta at the given value of theta. This is not asking you to find dy dx. This is not asking you to use any of these necessarily like other formulas that we put on the front page. This is just dr d theta. That is taking the derivative of r with respect to theta. So, how do I take the derivative of r with respect to theta here? What's the derivative of 3? 0. The derivative of 2 sine theta will be 2 cosine theta. And I'd like to evaluate that at theta equals pi over 6. So I'm going to say dr d theta at pi over 6 is equal to 2 cosine at pi over 6. What is the cosine at pi over 6, and where do we know that from? The chart. So the cosine at pi over 6 is positive root 3 over 2. Think your chart. Okay, this is like 30 degrees. We're still in quadrant 1. Where's the 5? Does your notes say 5? No. Okay. So this cancels, which gives me root 3. Not super difficult. Yeah? All right. Now, slope of the tangent line. This is different than dr d theta. This is asking me to find what? dy dx. Okay. How am I going to find dy dx? Okay, so what's my formula for dy dx? It's dy over d theta over dx over d theta. So what does that mean I need to find before I can even do this? I need to find equations for x and y. Okay, so the converting between the forms is not just playing with stuff the way we felt like it was on the last homework. You're going to actually need to find that. So let's go off to the side here. How am I going to find a representation for x? What do I know about my formula for x? R cosine theta. What is my y formula? R sine of theta. The only thing I have right now from the previous formula is what r actually equals. What does r actually equal? This. R is equal to that. So what do you think I can do with that? Plug it in. Okay, if I know what r equals, I can find a good representation for x and y. What is this actually doing here? It's not converting between the forms in the same way we did in the previous homework. Isn't this making like parametric equations? Just instead of with respect to t, it's with respect to theta. This is finding an x representation and a y representation. It's a parametric equation for our r. So that's going to look like r is 3 plus 2 sine theta. So I'm going to take that and I'm going to put that in place of the r. And I'm obviously going to clean this up a little bit before I go to take a derivative of it, hopefully. What should I do with that? Yeah, I'm going to distribute the cosine in. That's going to give me 3 cosine theta plus 2 sine theta cosine theta. Yes? All right, so what's it going to look like for the y? That's going to be 3 plus 2 sine theta multiplied by sine of theta. Now, I cleaned that up by distributing it. Does it really matter? No, because I'm going to have to use a product rule either way. So it's not the worst thing in the world, either direction. Which way do we feel like taking the derivative? The undistributed or the distributed?
I didn't distribute.
Okay. All right. So let's ignore the distributed. And let's go back to this version. All right, so from here, now I need to take the derivative of this with respect to theta. So let's look at the y first here, because that's the one that goes on top, yes? How do I take the derivative of that with respect to theta? What's the derivative of the first part? Because I have to use a product rule on this, yes? Derivative of 3 plus 2 sine theta is what? 2 cosine theta times the second sine theta plus the first 3 plus 2 sine theta times the derivative of the second. What's the derivative of sine? Derivative of sine is? Just cosine. Now I do the same thing but on the bottom with the x. Derivative of 3 plus 2 sine theta, we already said, is 2 cosine theta. Times the second is cosine theta. Plus the first, 3 plus 2 sine theta. Times the derivative of the second. What is the derivative of cosine theta? Negative sine theta. All right. Pause there for a moment. So now I would like to evaluate dy dx at theta equals pi over 6. So the top part will become 2 times the cosine of pi over 6. We just said that is root 3 over 2. Times the sine at pi over 6, which is 1/2. Plus 3 plus 2 times 1/2 times root 3 over 2. Now on the bottom, I might do a little bit of cleaning up because cosine times cosine is really cosine squared, right? So I'm going to make that 2 times root 3 over 2 squared plus 3 plus 2 times 1/2 times negative 1/2. So let's just do a quick cleanup on this, what that's going to look like. So this top left part, what's going to happen here? That cancels with that, and that becomes root 3 over 2. This parentheses, both places, becomes what? 4, right? Because 3 plus 2 times 1/2. So 4 times root 3 over 2 gives me 2 root 3, yes? What happens when I square root 3 over 2? That gives me 3 over 4, so 2 times that is 3 over 2. Plus 4 times negative 1/2, or minus in that case, is going to be minus 2. So if I want to make this nicer, well, first off, how far on a free response would I have to go with this? Okay, honestly, you probably would have been good here on a free response. You really need to show that you know the sine and cosine values, but after that, you probably wouldn't actually have to clean it up. Maybe this next step, you definitely wouldn't have to get common denominator or like get rid of the double fractions. For the sake of today, we're going to do that just to make sure we can. I would multiply everything by 2 over 2, which would give me root 3 plus 4 root 3 over 3 minus 4. What's root 3 plus 4 root 3? 5 root 3, and if you divide by negative 1, my whole answer is negative 5 root 3. You would have to do that if you were going to use the answer somewhere else or you were looking for a fully simplified version in a multiple choice. Okay? Questions? No? All right. The only other thing we're going to talk about with this today before we go back and look at a few of the graphs is points of horizontal and vertical tangency. What did we say about horizontal and vertical tangencies on the previous page? Okay, one of them, horizontal, is when dy d theta equals 0, yes? The other one, vertical tangent lines, was when what? dx d theta equals 0. Now, what do we have here? R equals. We have no x equals or y equals. What did we have to do on the previous one to find x equals and y equals? We had to say y is equal to r times the sine of theta, which means for this particular problem, that would look like 2 minus 2 cosine theta times sine theta. Yes? What about x? X equals r cosine theta, which means for this particular problem, that looks like 2 minus 2 cosine theta times cosine theta. Yes? What do we need to do to both of those in order to see where they equal 0? Take a derivative. So take a moment on both of those. Notice I've just divided this right down the middle to give us space for both. Take a minute on both of those and find your derivative, and we'll confer on that before we move on. I took my derivatives of y with respect to theta and derivative of x with respect to theta, and I did clean up on this, and here's why. Why do you think I cleaned this up? Yeah, we have to set this equal to 0. So we're going to have to be able to solve this somehow. Okay? So what I need you to bring back to your minds now is trig solving. Solving trig equations from last year. Yes, that's from our trig proofs. We're getting there, yeah. So I can solve one of them at this point in time. Okay? I can solve the dx d theta equaling 0. Let's look at that one first, and we'll come back to dy d theta in a minute. If I set dx d theta equal to 0 here, how would I solve that? Think factoring.
Oh, you pull this 2 sine theta out.
Yes. So the reason I can factor this one the way it is because I can pull out a 2 sine theta, which would leave me what? 2 cosine theta minus 1. And then what do we do with our factors? Set them both equal to 0. So we're looking for where sine of theta equals 0, or where cosine of theta is equal to what? 1/2. So think through your unit circle. Where does sine equal 0? 0 and pi. Where does cosine theta equal 1/2?
Pi over 3.
And?
5 pi over 3.
Mm-hmm. So I'd love to just write that down and say these are my points of vertical tangency. However, remember the rule on the front page. It's where dx d theta equals 0 or dy d theta equals 0, but not what? Both. So then I need to solve the other one, because before we start plugging things in, because an actual point of tangency is an x comma y or an r comma theta, I don't want to plug in things that are not going to work. So it's better to eliminate a theta when you see a repeated one before we go plug things in. Does that make sense? All right, so let's go back to the dy d theta. Someone tell me why I can't solve that one yet.
There's so many terms.
Yeah, there's a lot of different things. I have cosine squared, sine squareds, cosines. I need to get something simplified.
I know what you mean.
What do I need to do?
Cosine squared plus sine squared equals 0.
So you could try that, except I don't have a plus sign. What else could I do?
You could turn them all into the same.
Turn them all into the same term. So which one do I want to get rid of? The sine squared. What can I put in place of sine squared? 1 minus cosine squared. It goes in. By substituting that, that puts everything in terms of cosines, which is going to make this into a trinomial that I can factor. So this, I'm going to clean up a little more and make it 2 minus 2 cosine squared plus 2 cosine theta minus 2 cosine squared theta. Combining my like terms gives me negative 4 cosine squared plus 2 cosine plus 2. Where do I go from here?
Oh, cosine.
Before I do that,
Move the 2.
this is equal to 0. I'm going to set my dy d theta equal to 0. What can I pull out as a greatest common factor that would help me? And specifically a negative 2 would be pretty helpful, yeah? So if I pull out a negative 2, that's going to leave me 2 cosine squared minus cosine minus 1. I can keep factoring this. How does my 2 cosine squared split up?
Oh.
2 cosine and 1 cosine. Remember, we can factor these like trinomials. Where am I going to put the plus 1 and minus 1 from the other side? Or from the back part? It's got to be a minus 1 here and a plus 1 here, yes? Does that work out? Yeah? So this is then, when I set it equal to 0, looking for where cosine equals what? Negative 1/2. Or cosine equals 1. What values do I get for that?
2 pi over 3.
This is going to happen at 2 pi over 3 and 4 pi over 3. Where does cosine equal 1? 0. Again at 2 pi. Right? All right. So, before we go plugging anything in or looking at answers for this, what do we have to eliminate? 0. Because that is a both one. Okay? Depending on how the question is worded, you may have to go back and plug those in. This one does not specifically say what you want to get at the end of this. It could be an r comma theta. It could be an x comma y. You kind of have both. Either one is a little bit ugly on this one, but for this, from there, that would just be plugging in and getting values back out. So we're going to keep it with horizontal tangency happens at these two. And vertical tangency happens at these 3. Okay?